Hi guys, welcome to the final video in our lecture series on introductory concepts. In this video we are going to talk about the extremely important topic of unit conversion. So unit conversion is something that's going to help you throughout all of your science courses, and it's something that we're gonna spend a fair amount of time on in this lecture, and then you work through a number of practice problems. And we're gonna see that by really honing in and developing those unit conversion skills and being able to use units and keep track of units to help you solve problems, a topic called dimensional analysis, will be indispensable throughout these studies, and you'll find that you can in fact use the technique of dimensional analysis and if you're really comfortable with those unit conversion skills to solve problems even if you're not really comfortable with the underlying chemistry or physics that's going on. So after we cover this topic, you can come back and look at this joke and hopefully get some more humor out of it. So I encourage you to do that after the lecture and after you've worked through a few practice problems. Basically, what we're going to be doing is starting off with the basic topic of converting one unit to another unit. Okay. And this is going to come up all over the place, again, in your science classes more generally, but certainly throughout your chemistry studies, you're going to be, carrying out an interconversion between different units. Okay, and keeping track of these units and using units to help drive solution strategies in solving a problem, as I said, is called dimensional analysis. And you are going to find that you'll be using this for the vast majority of problems, certainly for the first half of this class, over and over and over again. So you need to watch this video, work through practice problems, read the text over and over again until you are very comfortable with these topics that I'm presenting right now. So the key to unit conversion is actually quite simple, right? We're going to treat little units as we would any little algebraic quantity. So for example, if I have a quick little algebra review here, if I have two variables, let's call them A and B, I don't care what they are. If I have a quantity B over A and I multiply by A, then what happens is those A's cancel out and we're left with B. Okay, so basic algebra. If something's showing up in the numerator and the denominator, it gets canceled out and you have only what's left over. Okay, so the A over A becomes 1. So here, that's the good news. That's all the math you need in order to understand the basic idea of unit conversion. Okay, so most conversion problems are going to be set up in the following form. You're going to have some given unit. You're then going to multiply that number with the given unit by a ratio of the desired unit over the given unit so that those given units cancel out and you're left with just that desired unit. Okay, and so this algebraic cancellation here is really the key. And of course, in order to be able to carry out this cancellation, we need to build up this ratio. And the ratio of the desired and given units has a special name. We call it a conversion factor. And we've actually already seen a number of conversion factors when we introduced the concept of these SI prefixes. So the example we've seen a number of times is, I threw out there that if you have 1 milliliter, that's equal to 0.001 liter. Okay, so that is an example of a conversion factor. I could set this up as 1 milliliter over 0.001 liters. Okay, and that would of course be a conversion factor that allow us to move from liters into units of milliliters. So the process for converting between units then comes down to essentially a two-step process. You need to determine the conversion factors, And the relevant conversion factors will, of course, depend on the problem at hand. And then you simply use those conversion factors to carry out the desired unit conversion. So the first one here will start with the conversion between inches to centimeters. So we're told that we're starting off with 12.5 inches, and we need to get that over to centimeters. So we, of course, need a conversion factor that relates the number of inches to centimeters. And that's given for us right here. You might not have that one memorized. 1 inch is 2.54 centimeters. So if we use that conversion factor, what we need to do is set up this ratio such that we cancel out our inches unit and end up in centimeters. So we need to put inches in the denominator. Okay? A common mistake I see students make is writing out a conversion factor. You oftentimes will identify the correct conversion factor, but sometimes mix it up, and you could, for example, put the 1 inch up top and the 2.54 centimeters on the bottom. And if you're paying attention to the algebra, you'll see that carrying out this operation essentially gives you nonsense. You end up with an inches times inches over centimeters. Okay, so this is a no-no. You want to make sure that these units are canceling as we see here, and then write out that unit and go back and carry out that multiplication. And so, of course, if we're going the opposite direction, then we can flip that conversion factor. So in this problem, we're starting off with centimeters, and we're wanting to go back to inches. So our conversion factor remains the same, but now we're starting off in centimeters, so now we want the centimeter unit in the denominator so that centimeters cancels out, and you're left with units of inches. Okay, so here's where unit conversion problems start to get a little bit more complicated and students start to struggle. Okay, so I want you to read this carefully and follow this advice, at least when you're first learning these problems. So the problem is what do you do when you have a multi-step unit conversion? In other words, you're not just simply going from, for example, inches to centimeters, but say going from yards to centimeters is the example below. Okay. So this is a very common issue. Many conversion problems will require multiple steps, okay? And what I want you to remember is that these multi-step conversion problems can be broken down into a series of two-step unit conversions. So the problem-solving strategy here is to begin with the given information. Then we're going to develop a step-by-step plan for carrying out the conversion, and then we're going to actually carry out that unit conversion process. So to see this in action, let's convert 1.76 yards to centimeters, given the two conversion factors. One is the number of yards in a meter, and the number of centimeters in a meter. Okay, so we know we're given a certain length in yards. We then need to map out a plan. We're not going to do any math. So step 2, we're not doing any math. We're simply mapping out a plan, a strategy as to how to move from the given unit into the desired unit with the given conversion factors. So we're in yards, so we go back here and we look at our given conversion factors. We have a conversion factor that takes us from yards to meters. Okay, so that's going to be our first step, yards to meters. Then we're going to be in units of meters and want to end up ultimately in units of centimeters. So then we're going to use our second conversion factor to get to our final answer in centimeters. Okay, so 2 steps represented by each one of these arrows. Okay, so then what I want you to do is actually write out the conversion factor by first ignoring actually the numerical values involved. Okay. So if we can just cover those up for right now, we'll bring them back in a second. I want you to just focus in on what units are present. Okay, so I'll completely block out those numbers because I want you to just focus in on those units. So we're starting off in yards, okay, and we want to convert from yards to meters, which means we're going to multiply by a conversion factor that is going to cancel out yards. So yards needs to be in the denominator and meters will be in the numerator. Then we're going to multiply by another conversion factor that will cancel out the meters, so meters must be in the denominator, and then centimeters in the numerator. By doing that, we will end up with a final unit of centimeters. Okay. Now, so by writing out these conversion factors in this way and holding off on really focusing on the numerical values, it'll essentially streamline the solution process by avoiding any confusion. What we'll find when you're learning new concepts here, it's very easy to overwork your short-term memory. You're trying to keep all this new information all in that short-term memory, and if you try and do too many steps at once, you'll basically get confused and sometimes just sort of feel like you hit a brick wall. Okay, so what we've done here is we've broken this down into individual steps. Here, this first one was just map out a plan. Now, using that mapped out plan, we set up conversion factors with the units in the correct ratio so they cancel out. Now that we've done that, then we can bring in the numbers. So bringing back in the numbers now, we can say, well, hey, we know that we're starting off with 1.76 yards. We know from the problem the conversion factor 1 meter is 1.095 yards and 100 centimeters in 1 meter. So we can now carry out the multiplication here. And then we need to keep in mind that we need to follow our significant figures rules. So the first value that came in here has only 3 sig figs. This is a defined quantity and our conversion factor here. So our final number should only have 3 significant figures. So we need to round off the 160.8775 to just 161 centimeters. Now, carrying out these multi-step conversions require a lot of practice. So let's go ahead and work through another example problem together. So in this problem, we're asked to convert 1.8 quarts to cubic centimeters. Okay? And we're given a set of conversion factors. In this case, we're given 3 different conversion factors: liters to quarts, milliliters to liters, and milliliters to cubic centimeters. Okay? So just as before, we're going to write down what we're given, and then we're going to use the conversion factors to map out a solution pathway. Okay, so again, ignore numbers for right now. All you're going to do is look at quarts and look through your given conversion factors and see which one of these has quarts. So we see that our first conversion factor allows us to convert between quarts and liters. So that's going to be our first step. Now we're in liters. Now you scan through the given conversion factors. Which one involves liters? Well, that's our second one here, liters to milliliters. So that's going to be our second step. Then we are in units of milliliters, and we're going to have to end up in units of cubic centimeters. So we're going to come back over here and then apply our third conversion factor, and then we will end up with our desired unit. Okay, so now that we have our pathway mapped out for us, we can start to build up that conversion by writing in the correct ratio of units in each one of these conversion factors. To go between quarts and liters, we need to cancel out the quarts, so we need quarts on top, quarts on bottom here, so the quarts per liter conversion factor needs to be set up as such: liters on top, quarts on bottom. Then, to cancel out the liters and get to milliliters, we're going to need liters on bottom, milliliters on top. And finally, to arrive in our final unit, desired unit of cubic centimeters, we're going to need to put milliliters on bottom in that conversion factor. Okay, then finally we can come back in and plug in all of those numerical values. And once we have the numerical values in there, it's a matter of simply, plugging those values into the calculator, and you'll arrive with a numerical solution. Now, once again, we need to look back and say, hey, we know we've got these defined quantities here, these conversion factors, but those aren't going to be impacting this the number of sig figs. So we need to look at our initial given value of 1.8 and conclude that we should only have 2 sig figs in our final answer. Okay, so in our next example, we're going to look at one of our derived units, volume, and we're going to carry out a unit conversion involving volume. So let's go back to that cube that we saw previously and say, hey, we've got this cube. It's 10 centimeters on each side. Okay, and we saw that we could come up with a volume by just taking that edge length and cubing it. So in this case, we have 10 centimeters cubed, and we're going to take the 10 cubed to give us 1 times 10 to the third, and then cube the unit as well. Now let's suppose we want to convert that volume in centimeters cubed to meters cubed. So to carry that conversion out, what you actually need to do is apply the centimeters to meters conversion factor, this guy right here, right? You need to apply it 3 times. Because remember, a centimeters cubed is effectively a centimeters times centimeters times centimeters. And so by just applying it once, you'd only be canceling out 1 of those centimeters. Okay? So you need to remember to apply this conversion factor multiple times. And this is actually one of the most common mistakes that students will make. So let's explore a number of different ways that we can write this down. If we are trying to convert between centimeters cubed and ultimately end up in meters cubed, what we're effectively doing is wanting to cancel out the centimeters cubed and with a meters cubed up top. Okay, and so we are doing that by applying the centimeters to meter conversion multiple times. So that would be 10 to the second. Specifically, we're applying it 3 times. So another way that we could represent this conversion is by taking the given conversion factor, there's 100 centimeters in 1 meter, and cubing that conversion factor. And given some nice little math review here, if we take a quantity, the quantity here in parentheses is conversion factor, raise it to the 3rd power, what you're effectively doing is raising each and every one of these terms to the 3rd power. Well, of course, 1 stays 1, but you're going to have 1 meters cubed. And then you're going to have 10 squared raised to the 3rd power. So 10 squared raised to the 3rd power, a power raised to the power gives you the 10 to the 6th, right? You multiply those 2 numbers together and raise the final unit. Of course, the centimeters cubed now cancels out. So we are left with units of meters cubed. And the final answer then is going to be, of course, in units of meters cubed, but we want to get comfortable without solving these problems without using the calculator. So that's one of the beauties of scientific notation here. We can actually figure out the answer without having to rely on the calculator. In fact, all we have to do is rely on addition and subtraction. When you have the same base, raised to different powers, and we're multiplying or dividing, all you have to do is add up all the exponents that are multiplied and subtract off exponents that are divided. So here we're going to have 3 minus 6, right? In other words, we're going to have 1 times 10 to the minus 3 meters cubed, right? Because that 6 is in the denominator there. So just a little bit more practice to drive home this fact that if you're dealing with a volume, same thing with an area, anytime you have a unit raised to a power, you need to apply the appropriate conversion factor the appropriate number of times to make sure you convert each and every one of those terms. And we can do this quickly by using these mathematical rules for working with exponents. All right, so now let's do a sample problem that involves multi-step conversion and dealing with volumes. So I want you to calculate the displacement, in other words, the total volume through which the pistons in the cylinders move in an automobile engine for a 5.70 liter engine, and then we want to convert that to cubic inches. So we're given a volume in liters. We want to end up in cubic inches. Now remember, in this example, I haven't listed out a bunch of conversion factors. So what we're going to be relying on first is your knowledge of those metric prefixes, right? And then we're going to use the conversion factors from the previous problems. So you know that you're in liters here. We know how to convert from milliliters to from liters to milliliters, and we can convert from milliliters to cubic centimeters using the conversion factor that 1 milliliter is 1 cubic centimeter. And then we saw previously that 1 inch is 2.54 centimeters. Okay, so we're going to use that prior knowledge from the previous problems to map out a little pathway. Then we're going to write out the appropriate units such that we carry out the conversions, liters to milliliters. Liters are going to cancel. Liter will be in the bottom, and we know there's 1,000 milliliters in 1 liter. Then we're going to convert milliliters to cubic centimeters. This is, of course, a trivial conversion. It's just 1 to 1. There's 1 milliliter and 1 cubic centimeter. But now we're in units of cubic centimeters. And then finally, we're going to carry out the cubic inches and cubic centimeters conversion. So to do this, we're going to apply the conversion factor, but we have to remember to raise it to the appropriate power. And I can't emphasize enough. I see so many students forget that power of 3 up there and come up with a very far out there answer. So basically, once you include that power of 3, you're going to get this answer coming out of the calculator. We're going to round it down to only 3 significant figures, and we see that we're right there about 350 cubic inches. So that's why oftentimes you'll hear car engines referenced as, say, a small block 350 Chevy engine. That is that displacement in cubic inches. And so one final problem here, just so that you can see as many example problems as possible here before you move into your own problem-solving activities. Another one, an example here involving volume. We've got a jet, and we need to make sure that we know how much fuel is in that jet. And so basically, if you have a 747 and it's fueled with a huge number of liters, so 173,231 liters of jet fuel, and we know the density of that fuel is 0.768 grams per cubic centimeter. We need to figure out what is the mass, total mass in kilograms of that jet fuel. So in this case, it's actually going to be useful for us to write down these conversion factors, in such a way that we're really drawing out what we're doing here. So basically, this conversion factor that we're going to be relying upon heavily is the density. So the density, okay, we saw this before, it's mass over volume. And what we're effectively writing down here is a conversion factor that says there's 1.68 grams in 1 centimeter cubed. Okay, so we're familiar with the first step. If we're trying to convert a given volume into a given mass, we're of course going to need this density, but the density here is given to us in cubic centimeters. So we need to go from our given unit of milliliters ultimately to cubic centimeters. And so the most natural way to do that is you first carry out a conversion, get to milliliters, then to use the 1-to-1 conversion factor to get to centimeters, and then use our density to get to grams. Remember, the density is given to us here in grams. And then use a grams to kilograms conversion. Okay? So liters to milliliters, we know that there are 10 to the third milliliters in a liter. We're going to put liters on the bottom to cancel out the units of liters. Then we're going to use our 1-to-1 conversion factor to convert our milliliters to cubic centimeters. Then we're going to apply our density, right? And we're going to multiply by the density so that the cubic centimeters cancels out, and we will be left with units of grams here. And then we'll carry out a final grams to kilograms conversion using the fact that there are 1,000 10 to the third grams in a kilogram, and we will arrive at our final answer. So once again, I went through that one a little bit quicker. If you're having some trouble with it, just look at this look at the problem, write it down step by step as we did before, and try and solve this thing. See how far you can get without looking at the video, and then as you get stuck, come back in and hit play. So that's it for the unit conversion, context. I want you guys to now go through, the sample problems, work a lot of these guys. I know I've assigned a number of these problems. I encourage you to work through all of them. As I said, unit conversion is extremely important for the rest of the course. And once you're done with that, you will have completed the Introductory Concepts mini-series.